Welcome! In this video we will be investigating the use of plasma technology to eliminate garbage and convert it into useful products and energy. Oftentimes this process is referred to as plasma gasification. The two most established methods to deal with municipal solid waste include incineration, which is essentially burning the garbage, or landfilling, which involves burying the garbage. Every year, the US approximately produces 220 million metric tons of garbage. Compressed, this would be enough to fill 81,000 football stadiums 2 meters deep in garbage. That's more than 400 square kilometers, greater than half the area of the country of Singapore. However, by North American standards, that's a really small area. The real benefit to gasifying our garbage is the energy and materials we can reclaim from it. Consider this. 1 ton of municipal solid waste, on average, will yield 900 kilowatt hours of electricity, 70 US gallons of water, several pounds of metal, and approximately 320 pounds of construction aggregate.
Plasma is referred to as the fourth state of matter, and over 99% of the universe is in the plasma state. So what is plasma exactly? If you were to take a gas and apply enough energy into that gas, at some point electrons will have enough energy to leave the atoms. This is known as ionization. And if over 10% of the gas is ionized, the formation of plasma occurs. Plasma consists of a soup of active species like electrons, charged particles, free radicals, photons, and excited atoms. The presence of these particles gives plasma its very unique characteristic, high reactivity. In the case of thermal plasmas, high enthalpy is also what gives plasma its importance in industry. The overall process consists of 4 major steps: waste handling, plasma treatment, gas treatment, and energy generation. First step, waste handling. Here, the municipal solid waste is brought into processing facilities and is then conveyed into a shredder. The waste will be broken down to small pieces. This is done to increase the surface area to volume ratio, making heat transfer more effective. Some facilities will also choose to remove most of the metals as they have no actual caloric value. Step 2. Plasma treatment. In this step, the shredded waste is conveyed to the plasma reactor, where it will be gasified by means of a thermal plasma torch. The extremely high temperature of the plasma torch causes disintegration of materials into their elemental components. Organic matter and plastic polymers will be broken into carbon, oxygen, hydrogen, and other basic molecules like halogens and sulfur. Any metals, metal oxides, or glass will melt down and collect at the bottom of the reactor as slag. The syngas produced will be used to generate energy, and the slag will be collected and can be resold as construction aggregate. Before going into details about the chemistry of the process, let's take a closer look at the plasma source. A DC plasma torch is typically used in the process of waste gasification. Around 2 to 6 plasma torches are usually present in the reactor to ensure homogeneous treatment of waste. Depending on the magnitude of application, the operating power could vary between 5 kilowatts to 2500 kilowatts. A typical plasma torch incorporates the following. To aid in the breakdown of the gas to plasma, an arc igniter is coupled with the plasma torch. This high frequency and high voltage igniter is directly connected to the plasma torch, and by sparking, it produces a sufficient amount of electrons to ignite the arc discharge. After ignition of the plasma, injected process gas, usually air or oxygen, maintains and stretches the arc discharge. Also, solenoid magnetic field coils around the discharge interact with the plasma to make it rotate at about 1,000 revolutions per second. This stabilizes the arc and boosts the heat transfer between the plasma and the incoming process gas. Temperatures of the system go up to 8,000 degrees Celsius, and that's why a sufficient water cooling system is required. Now, let's take a look at the chemistry behind the formation of syngas. Due to a long residence time in the reactor and extreme temperatures, all organic waste will be broken down. Let's take a look on what actually happens on a molecular scale. Here, long chains of organic molecules will be broken down by the reactive plasma into carbon, oxygen, and atomic hydrogen. These atoms will favor the formation of carbon monoxide and diatomic hydrogen molecules, the most basic and kinetically favored compounds. This mixture is known as syngas. Step 3. Gas cooling and cleaning. Syngas exists the process at around 1000 degrees Celsius, and cooling is important to stop unwanted side reactions like the production of toxic dioxins. Cleaning is essential to remove undesired chemicals that could be harmful to human health and the environment or damaging to the equipment. First, the gas is cooled down to a temperature of around 600 degrees Celsius. This is mainly done to prevent the formation of toxic dioxins. Some companies choose to recover the lost heat from gas cooling through heat exchange. Gas leaving the gasification unit usually contains suspended particles, so the next step will be to remove any suspended particles. Different companies use different methods to perform this step, and one particular method would be using a cyclone separator. In this unit, particles are removed by rotational and gravitational effects. As gas enters the cyclone separator from the top, it starts flowing in a helical pattern down the unit, then goes straight up through the center and exits at the top. Particles have a much higher momentum and thus will not be able to go through the helical path the gas takes. They will sediment at the bottom of the unit and then will be sent back to the gasifier to get reprocessed. The gas will then be further cooled, and it will pass through a series of filters to remove even finer particles. The gas is now free of particles and must undergo a chemical treatment to remove toxic substances. By passing the gas through a series of catalytic converters, any traces of nitrogen oxide will be removed. This step is then followed by a series of chemical scrubbing and stripping to remove vaporized mercury residues and acids. Now, the gas will be clean and ready to use for energy generation. Finally, energy generation. The syngas produced is fed to an internal combustion engine or a boiler to heat steam for a turbine to generate electricity. The converted energy will then be used to maintain the plasma torch, and the surplus electricity will be sold to the grid. Some industries may choose to compress the syngas and use it as an intermediate chemical in the production of methanol and other synthetic fuels.
As you can see, there are obviously plenty of advantages to plasma gasification, considering garbage is being consumed while producing value-added products and energy. One may be asking why the technology is not as widespread as landfilling and incineration. Well, one of the reasons is that plasma gasification is a relatively new technology compared to landfilling and incineration, and it's only because of recent technological improvements in the area of plasma physics that have permitted the creation of these new types of facilities. There are other reasons, though, as to why landfilling or incineration would be chosen over plasma gasification. What a municipality will choose to control its waste ultimately depends on costs, as well as other factors that can help in determining which method to choose. Currently, in North America, developing nations, and sparsely populated countries, landfilling is by far the most common method. Constructing a facility to incinerate or gasify garbage requires a much higher initial investment than simply leasing a plot of land and digging a large hole. Incineration and gasification may pay for themselves in the long run, but given potential maintenance or repair costs, landfilling is the least risky. Some of the concerns with landfilling involve toxic leaching of heavy metals, such as mercury from those new CFL bulbs, or other carcinogens from the landfill into groundwater. The effects can be partially offset by using impenetrable liners. When organic matter in the garbage is buried begins to decompose, methanogens, a type of bacteria that operate in the anaerobic environment, release methane to the atmosphere. New technologies are attempting to capture these, however, at least 70% of methane still escapes. This has resulted in landfill fires, which are a safety hazard, but also it should be noted that methane is at least 25 times more effective at trapping heat than carbon dioxide, making it a much more problematic greenhouse gas, even though plenty of the carbon remains sequestered underground in landfills. Plasma gasification ultimately burns syngas to generate energy. Syngas is simple, and the toxic emissions from burning it result in lower emissions than when garbage is burned like with incineration. Gasification is also more efficient overall than incineration and results in a higher energy yield per ton of garbage. The gasification of waste recovers other value-added substances from the garbage which energy cannot be yielded from, such as metals and glass, and is removed as slag. Plasma gasification is currently widely used for the destruction of biomedical waste and can also be used to concentrate radioactive waste. It works much like the waste disposal process, but since inputs tend to be much less than a municipal solid waste reactor, energy is usually not produced from the syngas or sold back to the grid. For the low-level radioactive waste, although the radioactive isotopes will never be destroyed, they will be concentrated in the slag 10 to 15 times greater than they were in the input stream, which makes long-term storage much more affordable considering the reduction in volume. The gasification process tends to make the radioactive slag chemically and mechanically very resistant, which is desirable considering it is radioactive. The Bill and Melinda Gates Foundation are funding an interesting project, which involves a toilet that gasifies the waste inputs. It may seem strange to reinvent the toilet so late after it's been invented, but the reality of the situation is that 2.6 billion people worldwide still do not have access to safe sanitation. This results in over half of the hospital beds in developing nations being occupied by patients who are sick due to waterborne diseases from a lack of sanitation. The project is focusing on gasifying the waste using microwaves and using the syngas to power a solid oxide fuel cell. The objective of the fuel cell is to provide enough power to ignite the plasma, making the system self-sustaining. The invention of such facilities would not need to have water or sewage lines to them and could be easily installed in rural areas or urban slums. Overall, plasma gasification is a promising technology. Compared to other methods for eliminating garbage, it is much more environmentally friendly, has less emissions than other destruction methods, and yields the highest amount of energy relative to incineration. It also yields value-added products and helps to conserve the limited amount of resources remaining on the Earth. The technology is constantly improving, and there are several companies, including local ones, such as Pyrogenesis and Plasco, that have successfully implemented them on an industrial scale. In the future, we should see the increasing presence of plasma gasification technologies in our lives.